Math 1314, Spring 2022, Tyler Junior College, Section 4.6, Radical Equations, Video 3, Solving Square Root Equations, Type 3. As if you were surprised that there was a Type 3, because I mentioned it more than once in the first two videos. Well, just a reminder, this is how we solve square root equations, and looky, I've got the mistake in there again. Cancel the square root. Step 1, if necessary, isolate the square root. Step 2, square both sides and cancel the square root. 3, if necessary, finish solving the equation. And 4, check your solutions. Some of them may be extraneous. So let's see if you can spot why this is a type 3. I bet it won't take you long. Solve the equation, check your solution. The square root of m minus 1 minus the square root of 3m plus 1 equals negative 2. I wonder why this one's different. It's funny because it's like a type 1 in the sense that the variables are all inside the square roots, plural, but it's clearly different because it has 2 square roots. So when I say type 3, a type 3 radical equation is one with 2 or more radicals, in this case square roots. Now we're not going to see the or more, it's a thing. But we will see equations with 2 square roots inside of them. And this may make you wonder, how on earth are we going to get out of this situation? Well, why don't we do this? And you might be thinking, but there's 2 square roots. How do I even do the first move? If necessary, isolate the square root. Can I isolate both of them? Well, sometimes you can and sometimes you can't, but you can always isolate one of them. The trick to handling this is not to focus on both square roots at the same time, but focus on getting rid of one of them at a time. And then later you can deal with the other. So we're going to do the exact same steps that we did before, just with extreme caution, especially when we square the first time, implying that we're going to square more than once. The general rule is you have to square once per square root that you have, not all at the same time, but in due time. All right, so we're going to solve this by doing the exact same thing that we did before, starting with isolating the square root. Now we have a decision to make. If we're going to do the first step, if necessary, isolate the square root, we have to figure out which one we want to isolate first, because now we have to make a choice. Do we want to isolate this square root by moving the other one to the other side? Or do we want to isolate this square root by moving the other one to the other side and then dealing with the negative? Well, I'm going to choose to isolate the first square root because it's easy to isolate. All we have to do is add the second one to both sides. So let's begin. First, isolate one of the square roots. Either will do. It doesn't matter which one we want to isolate, but anytime I see 2 of them subtracted, I will usually isolate by doing an addition move. I would rather do a move that turns negative things positive than turns positive things negative. And since the second square root is subtracted, to get rid of it, I would add it to both sides and it would show up as positive on the other. Now, if they're both positive, then you have to do a subtraction move and you can't help it. But if one of them is negative, like the second one, I would start by adding it to both sides. Adding the square root of 3m plus 1 to both sides will leave us a square root of m minus 1 on the left, because the minus square root of 3m plus 1 and the plus square root of 3m plus 1 cancel. And on the right side, we get 2 terms that we cannot combine, a negative 2 and a positive square root of 3m plus 1, excuse me. Don't write this. Don't write negative 2 square root of 3m plus 1, because if you do that, you just multiplied them, and I wasn't multiplying them. I was adding one to the other. When you add unlike terms, the best thing you can do is write them next to each other. I think starting with the positive part would be first would be a good idea. So we'll write the square root of 3m plus 1 equals negative 2. So really, we just moved one square root to the other side, changed its sign. Now, are we out of the woods yet? Ha! Hardly. we have the square root of m minus 1 equals the square root of 3m plus 1 minus 2. Remember, we already have a process for solving this, and we just did step 1. We isolated one of the square roots. So our next move is to square both sides. Now, and I'm going to emphasize the word carefully, square both sides. Now, this is where this problem gets a little bit annoying, because when you square both sides, let's catch the left side in a red parentheses. Square root of m minus 1, close parentheses, squared equals, and catch the right side in a red parentheses, open parentheses, square root of 3m plus 1 minus 2, close parentheses, squared. The purpose of the squaring move is to cancel the square root over the square root that we just isolated. In other words, to cancel the square root on the left. So that part's easy. We're left with m minus 1 on the left because the square cancels the square root on the left. Now, if you're hoping that the square on the right will just swoop in there and cancel the square root, I've got some bad news for you. In this case, it won't. If the minus 2 weren't there, and I'm going to put it back, but if the minus 2 weren't there, then yeah, we're squaring a square root, they would cancel. But it is there. So how do we deal with this? And the answer is something that you've already seen on a much smaller scale. You are basically squaring a binomial. That chunk minus that chunk. Yeah, we'll have to write this twice and FOIL it. Parentheses, square root of 3m plus 1 minus 2 times open parentheses, square root of 3m plus 1 minus 2. But wait a second. When we squared a binomial in the previous video, I reminded you that there was a shortcut for doing it. And we are about to capitalize on that shortcut. Because of the magnitude of this problem, I think it's a good idea to summarize this shortcut off in the margin. And we'll put it in green because that sounds like a good color. To square a binomial. Binomial. Let's put this in bold. I think I can bold that. There we go. To square a binomial. Colon sounds good there. Square the first term. Add twice the product of the two terms. Square the last term. Now this could be written symbolically, but sometimes I think a descriptive version is even better. To square a binomial, square the first term, add twice the product of the two terms, square the last term. Now if that doesn't sit well with you, then just FOIL the thing out carefully. But here it's really great because I'd like to square the square root, and I get to in this first part. Let me get rid of the yellow highlights so that I can focus on one piece at a time. Okay, so to square this ugly looking binomial, because half of it is a square root, we start by squaring the first term. That's pretty easy. When you square the square root, it cancels the square root and you're left with 3m plus 1. Okay. Next, you add twice the product of the two terms. So I have to think about multiplying these. Now I'm thinking about multiplying them and then doubling the result. Well, to multiply it, I would just stick them next to each other because one's a square root and one's a number. So I could just put minus 2 square root of 3m plus 1, but I have to double that. And when I double it, instead of minus 2, I get minus 4. Come on, 4, draw. So that part's where you really got to slow down. The middle term is twice the product of the two terms. And then the last part of squaring a binomial is pretty easy because all you have to do is square the last term. Now be careful, it's getting squared, so it will always come out positive. Negative 2 times negative 2 is positive 4. It takes some practice to be able to square a binomial quickly, but it is a nice skill to have. And in order to kind of connect the steps to the pieces of the binomial, I'm going to highlight each step with the result of it over here. So squared the first term to get the orange part. Add twice the product of the two terms to get the middle part. And then, of course, square the last term to get the blue part. So there's a little color coding for you. All right, let's clean this up and then see what we should do next. We have m minus 1 equals 3m plus 1 minus 4 square root of 3m plus 1 plus 4. All right, so now what? Well, remember, we were in this 4-step process. We did step 1. We isolated the square root. We just did step 2. We squared both sides carefully. Now it's time for step 3. If necessary, finish solving the equation. Well, hit the reset button, look at where we currently are, and ask yourself, how do I solve this? And more generically, what's the worst part of this equation I should focus on? And the answer is still a square root. So now we need to solve this square root equation. What we've done is we've turned a bigger square root equation with 2 square roots into a smaller square root equation with 1 square root. And you may be saying the equation doesn't look smaller yet, but it's about to. But at this point, we are doing step 3, finish solving the equation. And by evaluating where we currently are, we realize we're doing a different square root equation, which means we follow the process for solving a square root equation, which means we go back to step 1 and follow this process. All right, let me write this on the next page because I don't have any room to continue down here. We are currently at m minus 1 equals 3m plus 1 minus 4 times the square root of 3m plus 1 plus 4. And we're going to reset the solving a radical equation procedure because now we need to start solving this one by first isolating this square root. All right. Now, before we do that, you should notice that there are like terms all over the place. But let's think about multitasking here in an effort to get this square root alone. When we're isolating something, the first thing we do is get rid of the stuff that's added and subtracted to it. That means that we want to get rid of the following pieces from the right side. The 3m, which is added to the equation, the plus 1, not the minus 4 yet, because that minus 4 is attached to the square root with multiplication, so we'll get rid of it in a moment. But we still have a plus 4 over here. Now, we could try to combine like terms on the right side and then start isolating the square root, or we could just get rid of all these pieces at the same time. I choose the latter. Let's subtract 3m from both sides. Subtract 1 from both sides. And in an unorthodox move, also subtract 4 from both sides. And notice I'm lining up the minus 4 with the like terms. This is an uncommon move. Most teachers will say combine like terms before you start getting rid of things. But why can't I get rid of and combine at the same time? By subtracting away all the pieces that I don't want on the right side, it will allow me to cancel everything on the right side except the negative 4 square root of 3m plus 1. And on the left side, now I just have to combine like terms. So let's focus over there. I have an m minus a 3m. That's negative 2m. And I also have a negative 1, another negative 1, and a negative 4. Altogether, that's negative 6. Oops. Negative 6. Which gets us a lot closer to isolating the square root. Remember, we had to reset the solving the square root equation algorithm. And now we got to get rid of the negative 4. Now, the negative 4 is multiplied. And how do you get rid of something that's multiplied? Well, the answer is divide. But before we do that, do you really think this is the best move? It's not wrong. And it will cancel the negative 4 and isolate the square root. But on the right side, it's going to create fractions that will not divide completely. Neither number on the left is divisible by 4, which means that 4 will not cancel entirely. We're going to be left with some fractions. So we have one of two options now. Number 1 is to proceed with fractions. Number 2 is to not and change course. Now, I know I'm about to violate the step that I just said, which is isolate the square root. But let's be honest. What we're trying to do is to set up the equation so that we can square and get rid of the square root. Dividing by -4 will put us in that spot and create fractions on the left. But could we possibly square now? In other words, is it a legitimate move to square both sides of this equation right now? And the answer is actually yes. Now, I know I chastised people before for wanting to do something like that, distributing a square across an addition or subtraction problem. Never works, never works, never works in college algebra. You get to abstract algebra, there are systems where that worked, but that's not what this is. So you cannot distribute a square across a plus, you cannot distribute a square across a minus, but you can distribute a square across a multiplication or a division. Without getting too theoretical, if you know, please excuse my dear Aunt Sally, but write it like a totem pole, putting multiplication and division on one line, addition or subtraction on another line. There's a visual gimmick for knowing when you can and cannot distribute. When done carefully, you can distribute multiplication and division across addition and subtraction. You got to be careful with division because it only distributes from the right, but let's just pretend we're never in that situation. In fact, no, we'll leave it here. You can distribute from one level to the next. So you can distribute from exponents across multiplication and division. That D looks like a P and it's bothering me. You can distribute an exponent across multiplication and division. What you cannot do is skip a level. You cannot distribute an exponent across addition and subtraction. So if you're ever about to distribute and ask yourself, can I? Think of this, please excuse my dear Aunt Sally, totem pole, and remember, distribution does not work if you skip a level. If you don't skip a level, it probably works. There are some exceptions, but if you skip a level, it never works. So I can distribute the square across this multiplication, which is great because I can square the -4, I can square the square root, everything's going to be fine. All right, so let's do that. When you square -4, you get +16. And when you square the square root, it cancels, leaving a 3m plus 1. Notice I left parentheses around it because the 4 was multiplied across it, and the 16 is going to get multiplied across it as well. On the right side, we've got a squared binomial. For the sake of time, I'll just tell you the results. I'll call out the results, the steps as I do it. If I square -2m, I get +4m squared. If I multiply the terms and double it, multiply them to get +12m, negative times negative is positive, double it to get +24m, and then square the last term, square -6 to get +36. We're getting there. Let's move this to the next page. Pretty sure that's correct. Yes. All right. So before we finish this off, let's kind of review all the madness that's happened so far. We had 2 square roots, but we stuck with our plan of isolating one square root and then squaring both sides. Squaring both sides created a little bit of a mess because we were squaring a chunky binomial, the square root -2 in parentheses being squared. So we resorted to our shortcut for squaring a binomial: square the first term, add twice the product of the 2 terms, square the last term. And that got us down to an equation with 1 square root. And so we did the square root process from the beginning by isolating that square root. We did so by subtracting everything attached to it all at once and then squaring both sides before isolating the square root, because you can distribute a square across a times or a division. So we did. And now we're here. So now what? Well, now the obstacle is the parentheses, and we know how to deal with that. A little bit of distribution. And that will give us on the left 4m squared plus 24m plus 36. And on the right side, 16 times 3m is 48m plus 16 times 1 is 16. And now we identify the biggest problem left, and that would be the m squared. This is a quadratic equation. Surprise, surprise, surprise. Let's get the 0 on the right side by subtracting 48m from both sides and by subtracting 16 from both sides. I chose to empty out the right side because I'm looking ahead and I wanted my m squared to stay positive, so I wanted to keep it on the left. Speaking of the left, we'll have 4m squared. In the middle, positive 24m minus 48m is negative 24m. And then the constants are plus 36 and minus 16, which is plus 20. And then everything on the right side cancels because of our decisions. Now, we are at a quadratic that's ready to solve. We could break out the quadratic formula. We could try factoring it. But if you notice closely, the coefficients are all multiples of 4. So I could factor a 4 out of this, or I could divide everything by 4. I'll factor. Let's take out a 4 as a greatest common factor. That will leave m squared minus 24 divided by 4 is 6, plus 20 divided by 4 is 5, equals 0. We're almost there. Let's take it to the next page. You can hit the middle with the quadratic formula, but as I told you in the previous video, and I think this one, in both this homework and the previous homework, all your quadratics will factor. This will factor into m minus 5 and m minus 1. Those are the numbers that add to give -6 and multiply to give +5, meaning that we can now set each factor equal to 0. We don't have to worry about the 4 because it can't equal 0. We get m equals 5 and m equals 1. So finally, we're at the end. We're not at the end. Step 4. Oh my gosh, I hate this section. This is a section that really tests your perseverance and tests your patience on some of these higher level problems. I have confidence that you can handle it as long as you don't give up. Focus on one move at a time, and when you execute that move, take your time, make sure it goes smoothly. And at the end, you'll be rewarded with a sense of accomplishment. I promise you. All right, we still got to check our solutions. So let me get the original equation drawn here. Our original equation, I had to go back and look at it, was the square root of m minus 1 minus the square root of 3m plus 1 equals -2. We have two solutions to check. We're going to check x equals 5 first by substituting the 5 into each m and crossing our fingers. Now, when you're checking this, remember, you're asking the question, are these equal? So we will leave the question mark above the equal sign until we have an answer. Let's bring down the -2. There's nothing to work on the right side. On the left side, we can work underneath each square root simultaneously. Under the first square root, 5 minus 1 is 4. Now let's be a little bit more efficient with our moves here. Under the second square root is 3 times 5 plus 1. 3 times 5 is 15. 15 plus 1 is 16. The square root of 4 is 2, minus the square root of 16 is 4. 2 minus 4 is -2, and it worked. Hooray! But we got to check the other one. All right, let's check it, and let's see if I can make it fit in the space that I have available. I might be able to move some of this over and make myself just a little bit of room. Emphasis on the word might. Let's see if that'll work. I didn't grab the line, but there we go. Okay, I kind of made some room. All right, let's check the other one. We're going to check, what is it we're checking? We're checking x equals 1. That was our other solution, I believe. Or rather, I should say possible solution. Yes, and it wasn't x, it was m. No harm, no foul, but I want this to be technically accurate, so it should have said m equals. If you magically switch from m to x, it's not going to be the end of the world, not at this level. Are we going to check m equals 1? So in the first square root, we get the square root of 1 minus 1, minus, under the second square root, we get the square root of 3 times 1 plus 1. And the question is, does this equal -2? Well, just like before, there's nothing to do on the right side, so we'll just bring down the -2, and we'll work the left side. Under the first square root, 1 minus 1 is 0, minus, under the second square root, 3 times 1 is 3, plus 1 is 4. The square root of 0 is 0, minus, the square root of 4 is 2. 0 minus 2 is -2, and that one works also. Huh. But then again, I warned you in the previous video, there's no guarantees about which solutions will and will not work at the end. You got to check them all. So is this an obnoxious problem? Absolutely. But you're going to run across some of those in the homework. So now you've seen them. And that concludes the series of videos for section 4.6, radical equations. There is more to the story than what you've seen here. This is just all I'm going to hold you accountable for.